So in this video, we're going to show some examples of finding derivatives of functions involving the natural logarithm, and we're going to do it without using any logarithmic properties to simplify the process. In the next video, we'll show how to do derivatives using logarithmic properties. And the key for taking derivatives involving the natural logarithm is just to remember that if we have f of x equaling the natural log of some crap, when we take the derivative, we get 1 over the crap times the derivative of the crap. It's always going to have this form crap prime over crap after you've taken the derivative. So here I start with my f of x equals the natural log of x to the fifth. And again, I'm not going to use any logarithmic properties to simplify in this video. The next one we will. So the derivative in this case is just going to be 1 over the crap that's inside the log function times the derivative of the crap, which is going to be 5x to the fourth. And then you want to look at the numerator and denominator and simplify if you can. So we're going to get 5 over x to the fourth, and x to the fifth will simplify to just 5 over x. So in this example, I have a product of two functions. I have f of x equaling the function x squared times the function the natural log of x. I'm going to need to use the product rule when I find the derivative. So the product rule says take the derivative, when you take the derivative, to take the derivative of the first function, so the derivative of x squared is 2x, times the second function plus write the first function down and multiply it by the derivative of the second function. So it's just 1 over x is the derivative of the natural log. And then simplify if you can. So I'm going to get 2x natural log of x plus x squared over x will simplify to a single x. And then x shows up in each of the two terms. So I'm going to go ahead and factor that out, leaving behind 2 times the natural log of x plus 1. And we'll do one final basic example. So here I have the natural log function inside of the squaring function. And then inside the natural log function, we have a second degree polynomial. So we're going to use the chain rule 2 times to take the derivative. So I have f of x equals the natural log of x squared plus 2x plus 1. And this is all squared. And I do want to recognize that x squared plus 2x plus 1 factors as x plus 1 squared. So I would simplify my life a little bit by factoring before I take the derivative. So I get x plus 1 squared, and this is all squared. So to take the derivative, f prime of x, I need to take the derivative of the outer function, which is the squaring function. So the 2 is going to come down. I'm going to get 2 times the function on the inside, 2 times the natural log of x plus 1 squared, times, now the chain rule says take the derivative of the inner function. So the derivative of the natural log of x plus 1 squared is going to be 1 over the crap, which is x plus 1 squared, times the derivative of the crap that's inside the logarithm. So we have the derivative of x plus 1 squared is going to just be 2 times x plus 1. And then simplify things if you can. So I have a 2 times a 2 is a 4 times the natural log of an x plus 1 all squared. And this is going to cancel one of those occurrences of x plus 1. So we're just going to wind up with an x plus 1 in the denominator. I could do a little bit more with this using log properties, but I'm not. I already said I wouldn't use any log properties in this video, so I don't want to be a liar.